Hi, in this tutorial I'm going to explain how to do the finite element simulation of the plate with a hole problem. One important aspect of this problem is that the plate has two symmetries in x and y direction, so instead of modeling the whole plate, we can just model a quarter of the plate. Okay, let's open Workbench and then static structural and then right click on geometry to open the design modeler. First I will create the sketch in XY plane by creating a rectangle and a circle. Okay, let's add the dimension. Let's use a width of 0.5, height of 1, and diameter of 0.1. If you want to zoom in, just scroll up on the sketch. Now we need to trim these edges to create the hole. So go to modify and then trim. So select on this arc, this arc, this arc, this small edge, and this small edge. Now we have the quarter of the plate with a hole. The next step is to create a concept surface from the sketch. So go to concept, surface from sketches, then here click on one side of the sketch and then click apply, and let's use a thickness of 0.01. And the reason that we create the concept is that we want to mesh it using bilinear elements and not volume elements. And then click generate. Okay, now we have the plate. Let's open the model to apply the boundary condition and forces and do the simulation. Okay, let's mesh, but since the stress concentration happens around the hole, we need a finer mesh around the hole. So we are going to add some options for the mesh. So right click on mesh, then insert, and then sizing. So let's change the cursor mode to edge selection. So select this edge and then click apply. You see right now the sizing is uniform, but we don't want it to be uniform. So first change the type of definition to number of division and use 40 divisions, and then change the size function from uniform to curvature, and then bias type is this, and then let's the bias factor of 4. See, now we have a finer mesh close to the hole, and a coarse mesh far from the hole. And then we want to add another edge sizing for this edge. So I'm going to duplicate this edge size. Okay, and now let's change the edge selection from this one to this edge. Select this edge and then click OK. We need to change the bias type because we need a finer mesh around the hole. So select the first one, and okay, we are done. And let's also add a manual sizing for this arc. So go to mesh, insert, sizing, select this arc and click OK. Change the type element size to number of divisions, and let's use the number of division of 10. Okay, now we can mesh the plate. Okay, the mesh doesn't look bad. We have a fine mesh around the hole and a coarse mesh far from the hole. Now we need to apply the boundary condition, so click on static structural. So since we have the symmetric condition on this side and this side, we can apply the displacement of 0 for the x direction and z direction for this side. So displacement, and then let's select this edge and click apply. So we need to fix the displacement for x direction and z direction, and then for this edge we need to fix it for y direction and z direction. So, don't forget to click apply when you select the geometry. Now we should apply the force, so go to force and then line pressure, select this edge, click apply, and let's define the pressure by components. So in x direction let's apply a force of 1000 Newton per meter or Pascal. Now we can perform the simulation. So right click on solution and click solve. Let's add some results for deformation and stress. So right click on solution, insert, deformation and total. Again insert, stress, and one says stress. To evaluate the result, right click on solution and evaluate all results. So here is the total deformation and equivalent stress. If we want to create an output for the stresses along this edge, what we can do is, so I'm going to first create a selection for these nodes on this side and name them. So change the cursor selection mode to to box, we need to change the selection to node as well. We need to zoom in so that the box selects the nodes that we want. Okay, good. Now right click on one of the nodes that you have selected, create a named selection. So you can choose an arbitrary name, so I'm going to use nodes. Click OK, and then let's add another result for that named selection. So right click on solution, insert stress and equivalent 1 minus stress. For the geometry selection, change it to named selection and select the named selection that you created, which is in this case nodes, and evaluate the results. Now if you click on the equivalent stress 2, you see the stress distribution around this side. We can create an output for that stress. So right click on equivalent stress, then export, and export as text file. And then you can create a text file in the directory that you want. So in this case I'm going to create it on desktop. So let's create a folder, plate with all stress. And save. Now if we open that folder, you can see the corresponding node, the node and the corresponding stress. So here you see a duplicate of each node, and the reason is since we created the hole using the plate with a concept, through the thickness there are 2 nodes, but actually the results are the same because it's a virtual node and it's not real. If we want to check our finite element simulation and see what kind of element is used in this simulation, we can click on solution information, and if we scroll down here, we can see that Workbench by default has meshed the plate with shell elements, but we want to override this command and use bilinear elements. So click on a static structural, right click, insert, and then commands. Okay, if you read the first line, it says commands inserted into this file will be executed just prior to the ANSYS solve command. So we need to type the commands that are required prior to the solve command. So let's type finish, and then we want to open preprocessor, so prep 7. We are going to define an element type, which is 182. So 182 element is the bilinear element. Type 2, and then open solution, and then the next command is the solve command, which we don't need to type it. Go to solution, right click and solve. Now if we check the report again, see now instead of the shell elements we have the plain elements. Okay, I think that's enough for today's tutorial.